In the name of Almighty God, I am Mahsa Sankoshi, and today I want to talk about vehicle motion simulations and implementation in the Matlab software and also by the aid of the Simulink. So you see, we have a graphical development here, and we wanna specify the steer angle based on the x and y. You see that we have object oppositions in global x rect frame. Firstly, I want to mention that it's in based on the two-dimensional coordination, and there is a yaw, which is a p number divided by 10, which specify the steering angles, and then the delta is equal to yaw divided by 2. So we go through these simulations. The next is specifying the steering and vehicles set velocity. Here you see we have animation update intervals. These parameters will be stored inside the workspace, which is directly uh, connected to the Simulinks, and also there is a specific functions that we want to specify the velocity of the vehicle. So you see we have a one the round functions is a built-in functions, and one divided by animation FPS multiplied by edge underline fixed, and then we wanna multiply C to this edge underline fixed in order to gain the vehicle velocity. This parameter controls three things. The animation update to the screen is updated at this rate, which needs to be an integer multiple of fixed step size integration. The next one is the frames saved on this interval during movie. And then third one is how close to or how much faster than real time the simulation runs. See timing notes, and also you can find the radius, which is the absolute of vehicle length divided by minus 0.5, and another one is circumference to multiply by p multiplied by radius distance travel around the circle once node, and the next one is time for the one revolution circumference, or t is equal to distribution divided by velocity. So now I want to go through the Simulink sections. Here there is a simulation in a Simulink vehicle animation. You see that we have a vehicle motion based on the systems, which is society automatic engineering coordinates, and we have a different sections here in the left side, run setup and edit setup, that we overviewed on these two MATLAB code, and also we have some simulation time, which is a 5 seconds, and we can extract our velocity and acceleration and also a street angle here. It will go to the systems, which is a simple kinetic two-dimensional steer vehicle model, and we have a output as a x position and y positions here. When there is a when we go to the simulation and run these simulations, you will see that we have a frame, and the vehicle is inside the x and y frame coordinators, and there's a specific initial x and y for this vehicle, and after it gets the velocity and angle, it will be obeyed and go to the right sections to the and pass this exact distance from the first initiation coordination. So the final things we can gain, it is the plot two planar vehicles that I will discuss in the later and the next episodes.